Okay. So tell me some things that you noticed. Presley. They either switch or negate or flip flop. Okay, good.
Yeah, about what she said. If you flip it 180 degrees, they switch sides and one becomes positive. If you go like 70, it stays the same. But on 90, it would be all negative. Wait, no. That's just
If you start with a negative positive as your base shape, and then you go 90, then it will become both negative, and then when you go 180, the X will become positive, and then when you go 270, it will both become positive, and when you go 360, that's the same thing.
So 360 is the same thing. Okay, so let's just talk about this 90 degree right here. Okay, here are our 4 coordinates. How can you describe what happens with X comma Y from here to these coordinates? X comma Y goes to what? Y and X flip, and then which one becomes negative? The Y, right? Because look, all of these Y's are positive, but if we switch them places, these are now negative. Okay, cool. What about 180? If we start out with an XY coordinate, what happens with the coordinates?
The Y.
The Y negates. What about the X? Doesn't the X go negative too?
That one switches to
4, 1, 2, and 3. -4, -1, -2, -3.
it switches with the Y.
-4, 5 goes to 4, -5. -1, 3 goes to 1, -3. So they negate. X and Y both go negative. They go opposite.
Yeah.
Opposite X, opposite Y. Okay. What about what happens here? -4, 5 goes to 5, 4. -1, 3 goes to 3, 1. So first of all, X and Y switch, right? But is it as simple as X and Y switch? No, because the X negates, doesn't it? It goes opposite. Huh? Okay. Now here's the deal. This is going to happen every time we rotate, but I'm not going to make you remember these rules. Okay? What do we know? If we have a 90-degree rotation, we're going to be in the next quadrant. If we have a 180-degree rotation, we better be in the diagonal quadrant. Okay? If we have a 270 rotation, we're going all the way until we're next door in the quadrant. Okay? What I'd like you to do is go ahead and keep this stuff out, but get out your student journals, please. And we're going to turn to page 104. We are getting homework, but I will do my best to get some time in class to work on it. Okay, so rotation is one of our rigid motions, and we're always going to go counterclockwise. We are always gonna go counterclockwise. Amazon.
I find them all the time. I find them all the time at like regular gas stations.
Yeah,
Yeah.
Mr. Claire has to help me sharpen them in Mr. Truffles.
That why you wear A for body.
Do you have to like whittle it to sharpen?
Puts it on the sander,
Ah.
so kind of. All right,
Is this the only pencil you give out?
now, yep. Mhm.
But if more than 3 people in the
Then I figure it out.
So big.
All right, now, here on page 101, here are the rules we were just talking about, okay? When we rotate 90 degrees, yeah, A and B are gonna switch, X and Y are gonna switch and Y is negative, okay? For 180, X and Y, they stay the same, but they're not opposite, okay? 270, A and B switch, X and Y switch, and X becomes opposite. This is page 101. Is at the top?
That's interesting.
This is 104.
Yeah, it's 105.
This is 105,
Ah,
I think.
100 was our homework.
yeah, it was. I'm sorry, Presley. So 104 is where we just wrote down our definition, and 105 is right here. Okay. I don't think that you should remember this though. I think we should physically do the rotation. So this is what we're gonna do. Are you ready? Okay, let's look at number 1. Okay, and let's write down that J is -1, 2. K. Oh, no, it's not. This is stupid. J is -2, 4. K,
Oh,
they're counting by 2s. I'm ridiculous people. Do you see how this is 4, which means this is 2?
Yeah, that was really annoying.
Uh-huh. K would be -5, 1. L is -2, 2. And M is 1, 1. Now, instead of remembering what do I do with my X's and Y's, this is what I think you should do. If we're rotating 180 degrees, this is, you're gonna physically put your hands on your notebook. And I want you to turn your notebook 180 degrees. Do you see how my iPad is now upside down? And now, from the origin, with my iPad or my notebook upside down, upside down. Here we go. I am gonna go left 2, up 4 for my new J. Do you see what I'm doing?
wait, your iPad is upside down.
My iPad is up, so look at my iPad. J is -2, 4. So with my upside down paper, I am gonna plot -2, 4.
Wow.
You
can just count it.
And then K, I'm gonna plot -5, 1.
I don't think I did that right.
And L, I'm gonna plot -2, -2 on my upside down graph. And M, since M is 1, 1, upside down, I'm gonna go right 1, up 1. Then I'm gonna turn my paper right side up. And now I can identify, oh, J prime is at
How'd you make that shit?
2, -4. I connected the dots. You don't get how I connected the dots?
I just know. You connect the dots together.
Okay, so I took my paper and I rotated it upside down. And now with my paper upside down, you see how J is -2, 4?
Yeah.
With my paper upside down, I'm gonna go left 2, up 4.
Oh,
Like I'd be plotting -2, 4.
Yep.
Okay,
so I thought it was -2, 4.
so K is -1, 5. So with my paper upside down, from the origin, I'm gonna go left 5, up 1, because that's how I would plot -5, 1. But then when I turn my paper right side up, I can identify, oh, well, M or K prime, I actually plotted at 5, -1.
Oh, I get it now. I just think like L, I put in like -2, not
What?
L.
And what can I do for you? Did you plot the 4 points? No,
Yes.
upside down.
Yeah, it was really helpful.
Okay, so now turn your paper right side up. Now, actually, let's name these points. J is 2, -4 on the real graph.
I did it.
Days.
They don't look like roots.
You know, you don't want us to remember this. Like,
Harvey, if
I don't
you're
know
one
how
of
to
those,
forget it
well then use it, it's fine. Okay, if you're one of those people that this is something that really helps you, go for it. But I don't think,
now. It helps.
yes, okay. Now, if we're gonna go 90 degrees, let's look at number 2. Can we do that? Can we look at 90 degrees?
Yeah.
Do not turn your paper until I tell you. Everybody, let's talk about what these points are. R, S, T. Where is R? Is that -4, 0? S is -1, 5. And T,
-5,
Mhm.
1.
1.
All right, write those down. Let me tell you why I have giant pencils. Because I went through a lot of pencils in the first month and a half of school and I was annoyed. Okay, all right, are we ready? Now, if we want to rotate this 90 degrees counterclockwise, where's it gonna go? Which quadrant?
I don't know.
Gonna go down.
it's gonna go down.
To this guy.
Yeah.
So I am gonna turn my paper in the opposite direction. So I'm gonna take my paper and I'm gonna turn it to the right 90 degrees. And now I'm gonna plot -4, 0 from my sideways orientation. I'm gonna go left 4 for my new R. And notice how I'm now plotting in what will be the third quadrant. I'm gonna go for S, right 1, up 5. I said left 1, up 5. I said left 1, up 5. And then I'm gonna go left 5, up 1 for my new T. And then when we turn our paper the correct orientation, we can now identify what those coordinates are. So what did we do? We turned our paper to the right 90 degrees and we plotted from the origin how we would plot our coordinates. Alexa, is that okay?
Yeah.
Okay. So R prime looks to be 0, -4. S prime looks to be -5, -1. And T prime looks to be -1, -5. You what? Okay. So then, can you please, let's work on what coordinates these are, A, B, C, D. We're gonna write them down and then we'll talk about together how to do the rotation. What's A?
1, 1,
Okay.
4,
B,
4, 3,
C,
1, no, 4, 1.
3, 1.
Oh, oh.
D is 1, 2. You know what I learned yesterday? That in 5th grade, they plot coordinates.
They plot coordinates. That's about it.
What?
No, you don't until
You learned it in algebra.
Yeah, you learned it in algebra.
You're not from here.
I'm not from here.
I did teach my 5th grader slope because he told me he was bored in math and they were only taught 8 points. All right, so now we need to go 270 degrees. So we're gonna turn our paper clockwise so that our shape goes counterclockwise. So we're gonna turn it 90, 180, 370. And now from the origin, we can now go right 1 up 4 for our new A. We can go right 4 up 3 for our new B.
Do they like overlap?
No?
Why can't they just put the numbers on their board?
I don't know. It's bothering me also.
Why can't they just make the graph a little bigger?
No, make it.
I don't like the graphs that are like at an 8. I like the graphs that are like at a 10. I like the 10, the 100.
Okay, and now we can identify our new.
Isn't it so cool? Isn't that cool?
Negative.
Wait, so I'm gonna
So you have 2 options. You can memorize, switch X and Y and negate the X. You can memorize those 3 rules we talked about. You can memorize the 3 rules that are at the top of page 105, or you can physically turn your paper. I think for the majority of us, turning our paper makes the most sense. But you do what works for you. Okay.
Ms. Hillman, this is
Yeah.
based off of like the quadrants, so if it's like 90 degrees clockwise, then all of the coordinates would be negative because it's in the.
So
negative
like, if
quadrant.
this is gonna go 90 degrees clockwise, we're gonna go to here.
Then it would be negative X, Y, positive Y, right?
So, but the X's and Y's switch places. Cause like this would go to here.
Okay,
I'm so confused on how to get up.
yeah.
Okay,
So confused already.
So you
So-
rotate it 3 times.
okay, so you're always gonna go to the right, Alexa. So here's my paper. I'm gonna go to the right, to the right, to the right.
Not to the left.
Or not Beyonce.
So 1,
Yeah, because if I were to plot this point normally, I would go right 1 up 4. So once I turn my paper, I'm still gonna go right 1 up 4. Does that make sense? Yeah. Now briefly, we are gonna go back to page 104. And I wanna talk about rotational symmetry and then I'll get you to your homework. Okay?
Lucky pencil man.
So if we can rotate an image 180 degrees or less, and it's still the same image, that's what we call rotational symmetry. What? Nope. Do you know how to spell what?
Well, I did, then all of a sudden I like forget it.
Beautiful was a hard word for me to spell when I was.
Oh, Wednesday, so hard.
I have to say Wednesday. Mhm.
WEDX.
No, it's WEDNES.
See, I still.
Also, calendar, still don't like spelling the word. All right.
Go calendar.
Anyway, how many times can I rotate this guy and it still be the same
Everybody.
until we're back to
Four.
normal?
360.
4.
Yeah.
More people.
1, 2, 3.
No. No.
No,
No.
I just.
Wait, what?
you could,
Okay, so I can rotate it once and this goes to here. I can rotate it twice and then it goes to here. And then I can rotate a third time and we're back to normal.
is it how many sides it has?
I thought it just said.
It needs to look the same when you rotate it. And so I can rotate this 3 times and it still looks the same. Okay, which means what angle would that be
Acute.
specifically? Okay, so 1 full time around is what?
360.
So we could take 360 divided by 3 and our angle is
1200. 120.
What's 120 the angle of?
the angle of rotational symmetry.
The last like couple questions on the phone. I still find it.
Is that a unit? No, because you can draw down.
All right. What about our parallelogram? How many times can I rotate this?
I got 5. Brayden, what'd you get?
I can go upside down, right? And it looks the same.
You can't go 1.
Do you want me to show you that I can do upside down?
So.
Oh. Can I?
Which
Maybe
side?
not. Okay.
Boxing. Or boxing.
Okay, so we can rotate this twice, upside down and then back to normal, which means what would our angle of rotational symmetry be?
180.
180 degrees, because we take that 360 divided by 2.
It's not a rhombus.
That's a parallelogram. The parallelogram.
Not the rhombus.
A parallel. This is funny because I bought a shirt and I can't wear it because they did this wrong. This is a rhombus. It's a parallelogram where all the sides are the same.
Yeah. No.
This is a rhombus.
Oh.
Oh.
Oh, get
How'd they
that.
do it?
Let me just show you.
I don't get it.